Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of October, I'm going to try to upload 2 videos every day, one of the very easy to easy variety and one of the average, hard, or very hard difficulty level. And this is today's average difficulty level puzzle. And it's called From Dusk Till Dawn by Kodak. And here are the rules. Normal Sudoku rules apply. Each row, column, and region indicated by thick borders in the grid must contain digits 1 to 9 once each. So that means every row, every column, and every region is a 3 by 3 box in this case must contain the digits 1 through 9. 37. Digits in column 3 indicate the column in which the digit 3 appears in that row. For example, if row 4, column 3 is a 6, row 4, column 6 is a 3. Okay. The same is true of column 7 and the digit 7. Okay. So this basically just says which column the number 3 is in, right? And this says which column the 7 is in that row. Okay. Numbered rooms. Clues outside the grid indicate the digit which has to be placed in the nth cell in the corresponding direction, where n is a digit placed in the first cell in that direction. So, for example, if this was a 5, that would mean that the 6 would have to be placed in the 5th column. So this would have to be a 6. And that's what a numbered room clue is. And those are all the rules. If you want to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So this column means the 3s are in a different. Wait, we're in. No, that didn't make any sense. Just means this cannot be 3 or 7 because 6 cannot be here and 6 cannot be here. So the 3 and 7 cannot be in this position. So these 3 digits have to be, one of them has to be 1 through 3, one of them has to be 4 through 6, and one of them has to be 7 through 9 because they each have to be in a different box, right? So it could be, for example, these 3, then those 3, then those 3, right? Or it could be something like one's here and then the other one's here. Yeah. So basically, these have to be in distinct boxes. So there are 3 different entropic values. Same here, right? Because of the 3, of where the 3 is. Oh, wait, hold up. That's interesting. And digits in column 3 indicate the column. So that means this set and this set both point to the 3. And they cannot be the same, obviously. That's probably something interesting. Okay, so this cannot. For another thing, I don't think it could be 1 unless it is 1, right? So this could be 1, but if this was 1, it can't be also 6 too, right? So none of these can be 1, and it can't be 6. It can't be the number itself unless it would be 1. So this would have to be 2, 3, 4, 5, 7, 8, 9. This has to be 2, 3, 4, 5, 7, 8, 9. And it cannot be 4 because the 6 cannot be there. So, so we know the 5 is here. So this one of these has to be a 6. So one of these has to be a 6, right? Because it can't be 4 because of this. It can't be 6, right? If this was a 6, it can't be also along there. So therefore it has to be 5, which means this is 6. This could be 1 because it could be specifically in that same spot. Could be 2 or 3. Yeah, it could be a lot of things. So this is 5 here. This cannot be 5. So this cannot be 2 specifically. This can't be 1. This can't be 2 either. So this is 3, 4, 5. Can't be 5, 6, 7, 8, 9. So it could be 3, 4, 6, 7, 8, 9. This could be 2, 3, 4, no 5, no 6, 7, 8, no 9. Because if it's 9, this would have to be 5, and that's not possible. So this is 2, 3, 4, 7, 8. Then we have this. Okay, so it cannot be 1. It could be 2, 4, 6. Okay, so it has to be, could be 5. It has to be 2. So the 3 we know is here. 2, 4. So that could be 3. So it could be, this could be 3. 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 And this could be 3. So these are all could be, so it could be 1, 2, and 3. So for these 3, it could be 4, 5, 6, and it could be 8, right? It cannot be 7 and 9. So if, say this was a 1, right? If this was a 1, this is 3, and that's 9. That seems valid. If it's a 2, it would have to be 3. So 2, 3, this would be 8, and that's valid. If this is 3, this would have to be a 3 and 7, and that's valid. If this is 4, this would be 3, 4, 4, 3, and this would have to be 6, and that's valid. If this is 5, this would have to be 3, and that would have to be 5. So that's not valid. So this cannot be 5. So none of this could be 5. None of these could be 5. If this is 6, this is 3, and this is 4, and that's valid. If it's 8, this is 3, and this is 2, and that's valid. Seven. So 7 cannot be here. So, well, okay, yeah, we couldn't have 7 there. So 7 could be in 7. It's 1, 2, 4, 5, 6, 7, 8, 9. Yeah. That's valid. So we know the 1 has to be here. Actually, no, it doesn't have to be. It could be there. This has to have, okay, where is the 7? So this could be 1, 2, it can't be 1, 2, 3, 4, 5, no 6. It cannot be 7, 8, or 9. Oh, wait, hold up. This is 2, 4, 6, 7, 8, 9. It cannot be 3. And it cannot be 1. So this is 2. Since this is 2, first of all, that means the 3 has to be here. So it cannot be here, and it cannot be here, and it cannot be here. Right? So this has to be 3, which means this has to be 2. So it cannot be 1. It could be 2. It could be 4, 5, or 6, and it has to be 8. So this is 3. And there was another one. There's another thing that I understood from. This is 4 or 6. Oh, this can't be 5. How did I not move that? This is 8. So this is 8, which means this is 2. Wait. Okay. We eliminate 1 and 3 from that, right? We know this cannot be 5, right? If this is 5, that would mean 3's here, and this would have to be 5. So this cannot be 5. So this is 4 or 6. So we know the 3 is either here or here. And we know this is 8. So this is 2. This is 4, 6. 4 or 6, and it has to be 8 now. Right? Oh, wait, hold up. No, I think I was interpreting it wrong. Right, this could be 7, 8, 9. So 7, 8, 9 is one of these 3, not one of these 3. So the 2 specifically this part, right? It can't be 1 or 3. So, okay, we know this is 8, so this can't be 8. Because one of them has to be in the 8 series. This can't be 5. So we know 3 is one of these 2 spots. Interesting. This is 3. No, wait, I'm thinking something else. Right, this is 3, this is 2, so this has to be 1. Ah, right. Right? Because this can't... Wait. Is that right? I don't... Actually, it doesn't have to be, right? The 1 could be here, right? The 1 could actually be there. No, it can't be. This must contain 1 from 1 through 3, right? Only 1 and only 1 from 1 through 3, 1 and only 1 from 4 through 6, and 1 and only 1 from 7 through 9. Because this is essentially the entropy limitation. And this has to be also the same, right? 1 from 1, 2, or 3. But we know it's 3 here, right? So this has to be 2. And can't be 1 ever. Can't be 1, can't be 3. So this is 2. This is 3 because the 2 forces the 3's to be here. So what can be... This has to have a 1. So because of that, we know the 7 is here. So this cannot be 7. So the 6 has to be one of these 2. So 6 is either an 8 or it's a 9. It's also in 5. The 6 is in 2 and 3, and we don't know which. So this is... Right, this forces an entropy here. Okay. So this has to have 1 of 1, 2, or 3. This has to have 1 of 1, 2, or 3. Therefore, this has to have 1 of 1, 2, or 3. So all of these are entropic pairs, triplets, essentially. Which means 1 has to be 1 from 1, 2, or 3. 1 has to be from 4, 5, 6. 1 has to be from 7, 8, 9. This is the same. Therefore, this is also the same. Therefore, this is the same. And this, it works this way too. These are the same. So these both have to have entropic lines. This has to be entropic. This has to be entropic, right? So 1 from 2 or 3. This is 1. So we know this has to have 1 from 1, 2, or 3. We don't know which one it is. It could be 1, 2, or 3. But it can't be 2, we know. So this is from 2 or 3. So the 6 is from 2 or 3. The 7 is from 2 or 3. Because this is 1. Same here. This is 3. This is 2. This is 1, 2, or 3. This one doesn't tell us as much because we only have one numbered room line. So this could be 2 or 3. This could be 1 or 3. And this is 1 or 2. So we know this is 8. So this has to be 7 or 9. Yep. I mean, that's pretty obvious. Where's the 7? Okay, so this cannot have a 7 in 4 and 5. So it's either 2 or 3 or 8 or 9. Right? Okay. If this is 2 and if the 7 is 2 or 3, that means the 7 has to be here, which means this is 3. And that seems to fit. If this is 8 or 9, the 7 would have to be here, which means this is 9. This is 3. This has to be 3. And therefore... Okay. Right. So if this is 2 and 3, the 7 has to be here. We know the 7 is here already. So this would have to be 7, and this would be 3. Oh, okay, no, I was thinking the other wrong way. So if this was 7, this would have to be 9. This is 3. So therefore that's 3. Therefore this is 7. Yeah, that works. So we know 7s can be one of those or one of these 5. So that works. 5 could be one of those 3 or one of these 2. Huh. Wait. This cannot be... Okay, so this is 2. This cannot be 3. If this was 3, it would have to be here, and we know the 1 is already there. So this cannot be 3. This has to be 1. So this cannot be 1, so this is 2. This cannot be 2, this is 3. So therefore, the 7 has to be here. It's because the 3 is here. That means the 7 has to be here. So this cannot be 7. So this cannot be 7. Therefore, this is 2 or 3. So the 7's here, the 7's here. This is 3. The 1 has to be here then, which means this is 1, this is 3, and this is 2. And this one specifically cannot be 2. We have 3, 2, this is 1. 3, 2, 1, 7. Okay, so this is 8 or 9. The 3 could be in 1. It could be in 2. It could be in 3. The 7 has to be in 7. Sorry, in 3. And it cannot be in 6. No, it cannot be in 6 because this can't be 7. I don't know why that... Oh, because this is 7, right? And this is 7 because we know the 1 is here. So therefore the 7 has to be in the first column. So this can't be 7. This has to be 7. This is 3. So we have a 7 there. Yeah. This could be 1. This could be 2. This could be 3. This cannot be 5 because this has to be the 5. It cannot be 4 or 6. 4 because there's a 6 here, and 6 because it can't be 6. It can't be the same number in the first column of the number rows clue. So 6 is one of these two. 2, 4, 6, and it could be any of these. Oh. This is 8. So we know this is 7. This is 8. This has to be 9. Which means this has to be 8. Does it? Maybe not. This is 7. This is 8. This is 9. One of these 3 has to be 8 or 9. One of these 3 has to be 8 or 9. This could be 7 and 9, right? We know that the 9 has to be here, right? Because of the 3. So the 9 has to be here. The 8 has to be here. But we don't know if the 9 has to be here, right? So this is either... Oh, wait. This cannot be... This could be 7, 8, or 9. It cannot be 1, 2, or 3. So we know the 7's here. So this can't be 7. This can't be 7. This can't be 7. This can't be 7. It could be 5 or 6. So it could be 5. So this is 5, 7, 8, or 9. So 7 could be here, 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 or here. This could be 7 and 9, which would make that 8, and that would be 9, and that would be 9. So it'd be 7, 8. Right. We don't know there's a guarantee that the 9 could be here. So the 2 could be here. 2 could be here. 2 could be here. Why can't it be 5? I don't know. It could be here or here. Wait, no, it cannot be here. So this cannot be 7. So we know the 7's one of those two. So this can't be 1. So this is 4, 5, 6, 7, 8, 9. Right. So still could be 3. 6, 9. Oh, wait, hold up. Oh, no. We don't have anything. We only have this row of 2. We don't have a full set of 3, so we don't have that information. Hmm. Okay. Okay. So we have normal Sudoku, we have 3, 7, and we have numbered rooms. And that's it. So we have just this to go off of. This can't be 1 anymore. So one of these is 1, which means one of those is 7. Oh. This can't be 5. This can't be 5 because of that clue. This can't be 5 because of these 5. So this has to be the 5, which means this has to be 5, which means this is 3. So this is also 4 or 6. So this is 4 or 6, and this is 4 or 6. This has to be 3, and it has to have a 5 here. Now that's interesting. Okay, so say this was a 4. Then this would have to be, one of these would have to be a 6, right? So if one of these is a 4, that would mean the 3's are here, which means this is 6. So this could not be 6, so this would have to be 6, which would mean this is 8 and this is 9. This would be 4, so this would be 6. So this would be 3, 5, 8. Right, okay. So if this is 4, that means 3 is here, so this is 6. So this has to be 6, which means that these are 8. So this is 8. This would be 9. So this would be 7, 8. And oh, that's interesting. So if this is 4, this has to be 6, which makes that 6, which makes this 8. So the 9 would have to be here. Now, I guess it could be somewhere here, right? It doesn't have to be this specific digit. Okay, so that doesn't help. So this would be 7 and 9 here. So we'd have 3, 5, 8 here. Because this would be 4, this would be 6 then. So this would be 3, 5, 8. And since this is 3, 5, 8, this would have to be 1. So this would be 1, 4, and wait. 1, 6, and 7. Right. So that's if this is 4. If this is 6, that means this is 4. So the 3 would have to be here. If this is 6, no, this is 3. So this would be 4. So this would be 3. And this would be 4 and 7. We still could have 8 or 9 here. That doesn't tell us very much. Uh, N cell in the corresponding direction, where N is the digit placed in the first cell in that direction. We don't get very much information if this is 6, because then this becomes 4. Hmm. Hmm. I don't know. Yeah, I'm not sure what else we can go through. So here, we know where the sixes is in box 2. We don't know where it is in box 1 or box 3. Oh, this can't be 5, right? If this is 5, it could be 5. Never mind. I was thinking about something else. It has to be that way, that way. So 5 could be any of these spots, or 7, 8. Can't be 5 because it can't be itself, can't be 1, can't be 9, can't be 6. This is 2, 3, 4, 6, 7, 8, 9. Yeah. So 5 could be at many spots here. This seems kind of crazy, to be honest. This was only average difficulty. Huh. And we only have 3. We have the normal Sudoku rules. We have the 3 7 digits column thing. And we have the number rooms. Clue outside the grid indicate the digit would has to be placed in the nth cell in the corresponding direction. Yeah. So wait, hold on. No, that could yeah, this doesn't have to be. This doesn't have to have this doesn't have any entropic issues here, right? 3 could be anywhere in box 4. I'm just not seeing this. I'm not seeing how you can. You have the 1 here. Yeah, the 1 is one of those. It can't be 1 here, because if that's 1, this would have to be 7, which means the 2 would have to be here. Wait, why can't the 2 be there? Oh, well, because that can't be 1. Wait, what? No, if this is 1, this is... Oh. Wait, no. If this is 1, this would have to be 7, which would mean the 2 is here. That seems like it would be fine, right? Yeah, maybe I messed up. So this would be 7, and this could be 1. This could be 1 also, then. In which case it's not... The information is not very useful. Maybe we try filling things in and see if we break anything. So this is 2. Let's say this was 2. This would have to be 7. So then this would be 2. Right? Because it would be in the second column. I don't think this breaks anything. Are there enough clues here? There's no, like, any hidden, like, clues. Are there? Each row, column, and region indicated by thick borders in the grid. Okay, yeah. Digits in 3, 7. Clues outside the grid indicate the digit, which has to be placed in the nth. Yeah. Okay, that doesn't give us anything. Say it's 3. This would be 7. This would be 2. Then this would be 2. Interesting. Okay, so we are... Well... Okay. That tells us something, but not very much. We know... Okay, so we know one of those is a 2. That doesn't tell us very much, right? So we tried just being 3, right? So then this would be 7. That's 2. Where's the 3? It has to be there. So one of these is 2. So if this is 3, this is 2. Which means this can't be 3. It could be 3 here. Yeah, all we gain from this, we know, is that the 2 is one of those 2. It doesn't really help very much. Maybe I need a restart. Okay. Okay. Where can the 6 be in this box, in box 1? So far it can be 1, 2, or 3. Where can the 6 be in box 2? It cannot be in 4. It cannot be in 5. It has to be in 6. Just wait, hold up. It can't be in 4. It can't be in 6, because if it's 6, then it obviously can't be itself. So it has to be 5. So we know this is 5, which makes that 6. Okay. Where can 6 be in box 3? So far, it's 7, 8, or 9. Where can 1 be in box 1? It's 1, 2, or 3. 4, 5, or 6. Oh, wait, hold up. It would be this way. Where can it be in box 3? It could be 1, 2, or 3. It could be 4, 5, or 6. So this one doesn't give us anything. Where can 3 be in box 6. 3 cannot be in row 1 because it would have to be 1 and then it would obviously have to be 3 right on it. It could be in 2. It cannot be in 3 because if it's in 3, it would have to be 3. It would have to, if it was 3, then this would also have to be 3, right? So it has to be in 2. So we know the 3 has to be in 2, which makes the 2 have to be here, which makes the 1 have to be here. So the 3 has to be here, which means the 8 is here. So 8 is here because of this. 2 has to be here, so this cannot be 2. Okay, so 7 is in 1. So this has to be 7. So this cannot be 7. And since this can't be 7, this can't be 6. So 6 is one of these. Where is the 7 here? It cannot be 1. It cannot be 7. So it can't be 4, 5, and 6. So this is 2, 3, 8, or 9. If this is 8 or 9, so the 1 has to be either in 1 or 3. Cannot be in 3. So it can't be in 2 because of this. It can't be in 1 because of... Sorry, it can't be in 3 because of that. So this has to be 1. So this is 1. This has to be... This can't be 1 or 3. So this has to be 2. So therefore, this has to be 3. Therefore, we know the 7's here. We know the 7's here. So this has to be 2 or 3. So this has to be 2. This has to be 1. This has to be 3. And that's all we're really given. This could be 9 because there is no entropy restriction in these 3 squares. There is an entropy restriction here. There's 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 an entropy restriction here, and there's an entropy restriction here. Those are the only places for the entropy restrictions. I guess this one and this one too, but... So this is 9. So the 9 could be in any of these 2 spots. This is 8 or 9. We don't know which. You can never have 1 here, right? If it's 1, it has to be on itself. So this is 2 or 3, and we get back to the same issue that we have previously. So these entropy restrictions are only when you have 3 that are the same. Oh, this has to be entropy restricted too. This also has to be entropy restricted also. Right? So the whole, okay, all of column 7, 8, and 9 has to be entropy restricted. In the boxes, specifically. So this is 3, and 1 of 4, 5, or 6, or can't be 6. 1 of 4 or 5, 1 of 7, 8, or 9. This is entropy restricted because these 2 are entropy restricted. This is entropy restricted, same thing. This is entropy restricted, so this is and this is entropy restricted, so this is entropy restricted. And since both of these are entropy restricted, this has to be entropy restricted. This is entropy restricted, this is entropy restricted, so this is all entropy restricted too. I don't know if that tells us very much because, yeah, but we know then that this, so the back 3 rows are all entropy restricted. This is entropy restricted, this is entropy restricted, this is entropy restricted. We don't know anything about this. We don't know any entropy restrictions or not, right? This is like you have 2 out of 3, but this one doesn't have to be. right? And then we have no entropy restrictions in rows, so in sets of 3 there. So there's no entropy restrictions here. Um, we do know if this is 3, this would have to be 7. So this would be 2. And this 3 would force this to be 2. So we know the 2 is one of these. This cannot be 2. It can't be 1. Because it can't be... The 7 has to be here. So these can't be 7. So this is 5, 6, and it can't be 6, obviously. 5, 7, 8, 9. Which is fine. Yeah. Hmm. It doesn't tell us anything. So from this, we can't have 5 and 5. So this is 4 or 6. This is 4 or 6. And this could be 7, 8, or 9. This could be 1, 2, or 3. Yeah, it's fine. One thing is this can't be 2, right? If this is 2, this would have to be 3, but then the 2 would refer to 3. So this cannot be 2. Can this be 1? If that's 1, this would have to be 3, which would make that 2. Okay, so yeah, let's see if we can figure this out. So this cannot be 1, it cannot be 2. It could be 3, 4, 5, 6, 7, 8, 9, right? We know it can't be 8 because the 8 is here. If this is 3, this would have to be 1, right? So if this is 3, this is 1. This would have to be 9. And since this is 3, that would have to be 2. So this cannot be 3. It seems like it could be 4. Can it be 5? Oh, well, we know this is 5, so this can't be 5 because of this specifically. But it could be 4, it could be 6, it could be 7. It can't be 7. So it can't be 7. If that's 7, that would be 2, and that's not possible. So it could be 9, 4, or 6. Were the only places for 2. That doesn't help. I mean, it narrows a very tiny amount, but that still doesn't help. Huh. 1 through 9, it wants digits. Yeah. So the column makes it entropic. We know all these columns is set as in any box has to be entropic, but we don't know about any row. And in fact, it doesn't necessarily have to be. Unfortunately, we're only given 2 here, so then we don't know anything about this row. We know it has to be 2 different ones. That's all. This cannot be 1, obviously. Cannot be 5, obviously. Could be 2, 3, 4. Cannot be 6. Could be 7, 8. Can't be 9. That doesn't really tell us much. This is 2, 3, 4. Cannot be 5. Could be 6, 7, 8, 9. Yeah, that doesn't tell us much either. What happens if we have a 1 here? So say we have a 1 here. That would force that to be 8. That doesn't really tell us much. It just says that 6 has to be in 3 or 5, right? Because it can't be 8 anymore. If this is 1... Huh, this is interesting. Maybe I have to go through these. We just tried the 2 and 3s and we did get a little bit extra information. Not much, but 2 has to be 4, 6, or 9. If this is 2, this is 4, right? Other way around. If this is 4, this is 2. So this has to be 6 and 8. So we know the 3 is here. This has to be 6 and 8. Which means this is 2 and 4. Right? So this cannot be 2, so this can't be 3. This can't be 4, and it can't be 6. So it can't be 5, period. Maybe this is the way to go. Okay. So if the 2 is there, if this is 4, this has to be 2. This can't be 2, 4, or 6 because the 3 can't be. The only one could be was 2, 4, 6, 7, 8, 9, right? Can't be. It can't be 8. If this was 8. Okay, so this can't be 2, 4, or 6 then, if that's the case. Right? So if this is 4, this is 2. It can't be 2 here. It can't be 4 here. So it can't be 6 because it can't be that way. So the 3 is not there. So 3 cannot be in any of these spots. The 3 would have to be here. Right, let's just do... Where are the 3s? So the 3s have to be here, here. And then it could be any of these. We don't know which. It cannot be this one specifically because we tried that out. So we tried that being 3, which means this is 2. But then the 3 has to be in 1, so that doesn't work. So we tried 4. If this is 4, this has to be 2. This can't be 4, obviously, so this has to be a 6. So the 3 has to be here now, which means this can't be 3. But this can't be 2 or 4, so it can't be either of these. Which means it has to be either 7. So say this was 3, right? Then this would be 7. But the problem is, then this would, okay, this would be 9. That seems okay. So this would be 7 away, and this would be in 3. Yeah, okay, that seems okay. So that seems possible. What about 8? So if this was 3, this would have to be 8. This would have to be 2, so that's not possible. So it could work. It only works if this is 3, if 4 is there, right? So that would also eliminate 2 and 4 here. So 5 would have to be here or here. We don't know which, right? So that would be 3 if that's the case. What happens if this is 6? Then this would be 2. The 3 could not be 4. It cannot be 2. It cannot be 6. So if it's 7, sorry, if this is 3, this would have to be 7 again. No, sorry. If this is 3, this would be 7, which would force this to be 9. Okay, so then this works again. Then we have 3 and 9 and 7 in those situations. Otherwise, can it be 8? Or not? This is 3. This is 8. This would have to be 2, so no. So in both of those, in 4 and 6, we led to this being 3, this being 9, this being 7, and this being 9. So in both cases, this is 3, 7, 9, right? What if this is 9? Then the 2 has to be here, which means this is 3. Which means this is 8. Okay. That seems reasonable. This can't be 1 either way. Okay, so let's go through the possibilities here. If this is 4, let's just make it. If this is 4, that means this is 2. This can't be 2 or 4 or 6. And this has to be 3. So this would be 7 away. So this would be 9. Right? So this would have this situation. You would have a 4, a 3, a 2, a 9, a 7. Right? If this is 6, and the other ones could be whatever. If you have a 6, this is 2. Again, it cannot be 2, 4, or 6. It cannot be 8. So if this was 3, this would have to be 8. But then this would have to be 2. And then we already can't have that. So this would again be 3. So if this is 6, this is 2. This would again have to be 3, 9, and 7. If this is 9, that means 2 is here. That means 3 is here, which means this is 8. So we know this is 3 or 8. We have 4, 6, or 9 here. We don't, this could be 9. So this is 2 or 7. I mean, it does, so that gives us information about, so we know limitations about this square, this square, this square, and now this square. The problem is that these can be whatever, right? Um, This can be whatever too. But, at least we've got some information, I guess. This is 2 or 7. So 3 is either here or here. Wait, hold up. Oh, no, that's fine. Yeah, this could be 9 and that could be 7. Then this would be 8 both times, which doesn't give us much. Does it? Maybe it does give us something. Okay, so let's go say the 4 route, right? 4, 2, this is 3, this is 7, this is 9. That means this has to be 6 or 8, right? Does that tell us anything? Don't know. This is 9. So, yeah, the 7 can't be there. This can't be 3. This can't be 2, obviously. So, this is 1 or 5. This can't be 2. This is 1, 5, or 8, 6. This can't be 6 specifically. This is 1, 5, 6, or 8. Oh, wait, hold up. This is 6, so this can't be 6. This becomes 2 and 4. Oh, interesting. This can't be... So this is 6 or 8. This can't be 3. Because this is 6 or 8. This is 6 or 8. This is 2 and 4. Right? 2, which makes that 3, and 4, which is that 3. So we know... I don't know if that gives us any information. I don't think that does. Why did I delete the 3s? I don't even know. How did I do? Oh, I was just... I don't know why I had 3. Okay, never mind. I don't know why I had the 3 there. Okay, so... This 3 is just weird. I don't know why I have it here. I think I was trying to figure out the 5s, but I put 3 there instead. Okay, so that gives us that information, which isn't too helpful. And we've got a dog barking in the background. This dog is kind of annoying. What happens if this is 6? That's interesting, isn't it? So if this is 6, this becomes 4 and 8. So this has to, again, this is 2. This has to be 3. This becomes 7. This becomes 9. So this has to be 2 and 6. So this can't be 6. So we know the 6 is here, which means that this has to be 8. So this has to be 9. So this has to be a 7, 8 pair here. This can't be 9. Does this tell us anything? I'm not really sure. So this is again 1, 5. It can't be 6 or 8 or 4. This becomes 1, 4, 5, 8. This is 1, 4, 5, 8. Can't be 1, obviously. So this is 4, 5, 8. The 8 does have to be here. The 8 is here. So 6 is one of these two. This becomes 4 and 8. Which means the 3 is here, so this can't be 3. Doesn't tell us very much. Three's one of those two. Three's one of those two. Huh. It's just not giving us much information, unfortunately. Maybe. I don't think the. I mean, we can try this, but I don't know how much this helps. So this, if this is 9, that means this is 2, which makes that 3, which makes this 8. So this becomes 1 of 4, 6, 1 of 4, 6. I mean, that's interesting. Okay, so then none of these can be. Oh, maybe this is it. None of these can be 4 or 6. Okay, no, that doesn't tell us much. This can't be 4 or 6. This can't be 4 or 6. So this can't be 9. So this is 8. So this is 6. So this can't be 6. This can't be 4 or 6. This can't be 4 or 6. So 4 or 6 has to be here. And we have 1, 5, 7, 1, 5, and 7 also. This can't be 7. So this is 1, 5. One thing we found out is this has to be 1, 5 no matter what. If this is 4 or 6, this also has to be 4 or 6. If this is 9... Oh, no, 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 no. Oh, interesting. So one thing we found out is none of this can be 4 or 6 because we have a 4, 6 pair and a 4, 6 pair here, which eliminates 4 and 6 from being here and here, which means this has to be the other 4 or 6. So it's the other way around. This is 4 or 6, and this cannot be 4 or 6. So this becomes 1, 5, 7. So this is 4 or 6. Interesting. Which means 7 is in the 4 or the 6. So this cannot be 7. Huh. So we have a little bit more information, I think. So if this is 4 or 6, this is 4 or 6, so this cannot be 4 or 6. So this is either 9 or this is 4 or 6. This could be 1, 5, or this is 4 or 6. So we have this small limited information too. Right, because so this would be 4 or 6. It wouldn't be 4 and 6. Let's just go down that path again because I think that might be leading to something. So this is 9, this is 2. So this would have to be 3. This would have to be 8 then. This is 4 or 6, this is 4 or 6, this is 1, 5, 7. This is 4 or 6. And it would have to be 7, 8, or 9 still. Oh, interesting. So then this would be 4 or 6. This would have to be 7, 8, or 9 here. This would be 4 or 6. This would have to be 5. Does that tell us anything? I'm not really sure if it does. One of these is 4 or 6. This could be 1 or 2. 1, 2, or 3. Yeah, it doesn't really tell us too much. It does give us a little bit more information, but not enough. So we have, okay, these are limited to what those are right now. 1, 4, 5, 6. The problem is that there's no entropy guarantee here, right? So this could be 7, 8. This could have none from 7, 8, or 9. Oh, hold up. If this is 9, okay, so that's another thing we forgot. If this is 9, this can't be 9, so this can't be 8. This can't be 9. This becomes 2, which forces this to be 3. Forces this to be 8. This is 4, 6, 4, 6. So no 2, no 3. This can't be 2. This has to be 8. So the 6 has to be here. This can't be 6. We know the 5 is here because of entropy. So 1 from 4 through 6 is here. 1 from 4 through 6 is here. This has to be 5. 1 of 4 through 6 is here. 1 of 4 through 6 is here. There's nothing about entropy here. We know the 7's here. So one of these is 1. One of these is 7, 8, or 9. This becomes 8. This becomes 9. One of 1, 2, or 3 is here. So this is 7, 8, and 9 also. This is also 7, 8, and 9. This doesn't tell us very much. So that 3 is described by here and here. The 2 is described by here. The 7, so this is 1, 5, 7. This is 1, 5. This is 1, 5, 7. So, yeah. This is 4, 6. So 3 is either here or here. We don't know. So we have 2, 3, 2, 3, 4, 6, 8, 9. So this can't be 6. This can't be 3. Where did I get 7? Remove the 7, put the 9 in. Yeah, it still could be 2, 3, 4, 7, 8. Does this tell us anything? Not really. That was interesting. Not too helpful, but interesting. Okay. So what if the 6 is here? That would force this to be 9. Oops. This would be 9, so this would have to be 8. So this could not be 9. So we have 2. 2 is one of these two, which means this is 7. So we have 7, 3. This is 9. This cannot be 4, 6. So we have 4, 6, 8, 4, 6. 2 has to be one of these two. This can't be 6. So this would be 4, this would be 4, so this would be 6, so this would be 4, this is 2, and this can't be 3, so this is 6, this can't be 9, so this is 2 and 4, which means the 3 has to be here. This is 6, 8. This can't be 2. So we have 1, 5, 6, 8, right? This is 1, 5, 6, 8. Can't be 1. This can't be 6. So 6 is either here or here. This is 1 or 2. We have 7. We have 9. Okay, so this is 9. And then we have 1, 5. And 2. This is 5, 6, and 8. 7. 7's here. 5, 6. Cannot be 8. So we know this. Yeah, we know this is 8. This is 5 or 6. So the 7 has to be one of those 4. I don't know if this tells us anything. I mean, this seems reasonable. This is 6. So we know this is 4. So this would have to be 3. So this cannot be 3. Right, this has to be 6. This has to be 4. So this is 6. This is 1 or 2. And this could be 1, 2, or 3. And this is 1 or 2 with 5. So we know the 3's here. The 3's here. So this has to be 4 and 7. Oh, that's interesting. Yeah, the 9 isn't helpful, right? Wait, oh yeah, this can't be 5. Oh wait, hold up. Okay, one thing we do know. Okay, we do know also another thing. This has to be 5. This can't be 5. So this has to be 5 also, which means this has to be 5. So we know the 3 is here for sure. So this can't be 3. Okay, that is one information that we didn't know before. So this is 5, this is 5, this is 5, so this is 3. So this cannot be 5, so this can't be 5. It could be 2, this could be 5, these 2 could be 5, or this could be 5. Not that it helps that much, but at least we got a little bit more information. So this is 5. Oh, this is 4 or 6 also. This is 4 or 6, this is 4 or 6. I don't know if this tells us very much of anything. It's getting dark, so I'm going to pause this recording and maybe we'll pick up later.